Okay, we are live.
Right, we are reconvening our morning hearing and taking up page 303, an act relating to the use of septic sludge and biosolids. And we are going to start off with a walkthrough legislative council.
This is Mike O'Grady with Legislative Council. I'm going to walk you through an act relating to the use of septic sludge and biosolids. So beginning on page 2 of the bill, let's just provide some regulatory framework context. So sludge is managed under the solid waste chapters in Title 10 and under the solid waste rules that are adopted by A&R underneath that chapter. So when you are going to amend the law related to septic and sludge, even though you might think it is a water or wastewater subject matter, it's actually within the solid waste chapters. And so the first section is amending definition section under the solid waste chapter. It adds definitions of biosolid septic sludge wastewater treatment facility. Definitions of biosolids, septic, and sludge are all drawn from A&R solid waste rules. So biosolids are septic or sewage sludge derived in whole or in part from domestic waste that have been subject to a treatment process for the reduction of pathogens and have been demonstrated to meet the applicable requirements and agency rules for vector attraction reduction and pathogen reduction. Sometimes biosolids or some types of biosolids are referred to as exceptional quality biosolids. And so if you hear that term, it's because they've gone through treatment and met certain standards. Septic means the liquid and solid materials pumped from a septic tank, portable toilet, or cesspool or cleaning. Sludge is any solid, semi-solid, or liquid generated from a municipal, commercial, or industrial wastewater treatment facility or process, water supply treatment plant, air pollution control facility, or any other such waste having similar characteristics and effects. Sludge includes Class A and Class B sewage sludge as those terms are defined in federal law. A wastewater treatment facility has the same meaning as in section 1295 of this title.
Can you just pause and let us know what Class A and Class B, or like, what's that mean?
Well, it's harder than it sounds because they say as defined in this chapter, and there are different standards or uses for Class A and Class B. Hold on a second, let me try to find. Can I get back to you on that question?
You may, we
Tried to be prepared for that, but I
like our A&R folks
Yeah.
will be able to help us with that when they come on board. Great. All right, no worries. Oh, Representative
Just
Austin.
vector attraction, what's that mean?
pests, rodents, etc. And then a wastewater treatment plant that is a treatment plant, collection system, pump station, and attendant facilities permitted by the secretary for the purpose of treating sewage. Then moving into section 2, you're amending a section of law that currently is.
Oh, Representative Bartholomew.
Sorry, just on under sludge, air pollution control facility, how does that work? How does that make sludge?
There are things that are basically managed with ash or the components of filtration from an air pollution control facility that is taken out of the filters and creates sludge.
I see. Okay, thank you.
Here on page 3, line 3, section 2, you're amending a section relating to testing of solid waste prior to beneficial use. Use of these substances is often called beneficial uses. You just passed a bill from the Ag Committee about beneficial substances, which is soil amendments and things like that. So this is a fairly common term, the beneficial use. But you're changing it to a prohibition on land application of sludge, septage, and biosolids, and sale of compost and other agricultural products and materials containing sludge, septage, and biosolids. So the directive to A&R to adopt rules to establish a testing program for all sewage, sludge, or similar liquid waste would be prior to their beneficial use is struck. Instead, on page 4, you have a notwithstanding any provision of law to the contrary. So whether or not there's federal law that allows it, a person shall not apply or spread on any land in the state septage, sludge, or biosolids, compost material that includes in its production the use of septage, sludge, or biosolids, or any other product or material that is intended for use as a fertilizer, soil amendment, topsoil replacement, or mulch. And you could probably replace all those or some of those with the term beneficial substances, or for other similar agricultural purpose that is derived from or contains septage, sludge, or biosolids. And then notwithstanding any provision of law to the contrary, again, even if federal law allows it, a person shall not sell or distribute in the state compost materials that includes in its production the use of septage, sludge, or biosolids, any other product or material that is intended for use as a fertilizer, soil amendment, topsoil replacement, mulch, similar agricultural purposes that is derived from septic sludge or biosolids. Then on page 5, line 4, section 3, you are in the main section in statute regarding certification of solid waste facilities. Certification is the term used in solid waste statutes basically for permitting a solid waste facility. And you cannot construct or alter or amend a solid waste facility without a certification. But you will see on page 5, lines 6 through 10, it says no person shall construct, substantially alter, or operate any solid waste management facility without first obtaining a certification from the secretary, except for sludge or septic treatment or storage facilities located within a fenced area of domestic wastewater treatment facility. So within a wastewater treatment facility, they are managing sludge and septage as a waste, and they don't need a solid waste facility certification for that because they already have a permit from A&R as a wastewater treatment facility. The exemption for sludge or septage shall exist only if both of the following are met. So what's being struck is that the facility does not use a process to reduce pathogens further in order to qualify for marketing and distribution. So if you are using something at your facility to reduce pathogens in order to qualify for marketing, you currently need a certification. But this is basically moving away from that. But both of the following are met. The facility is not a drying bed, lagoon, or non-concrete, and I'll tell you why. We're getting to that in a minute. The owner of the facility has submitted a sludge and septage management plan to the secretary, and the secretary has approved the plan as conforming with the requirements and the established standard for proper management of these materials. So you will see on page 6, you've already seen the prohibition on the sale of beneficial substance products that were made from septic or sludge. The wastewater treatment facilities can no longer make those beneficial substances from septic or sludge. There's no more exceptional quality biosolids. They are not making those anymore underneath the spill. And therefore, that language on page 5 about the treatment facility not using a process to reduce pathogens in order to qualify for marketing for, they don't have, you don't need that. They're not marketing and distributing anything anymore because they're not allowed to sell those products or use those products anymore.
You're doing that in this state now.
I don't know the exact number, but there's a good amount.
Wastewater treatment facility?
We can.
So moving on page 6, line 5. You're striking the authority of the secretary to authorize the land disposal or management of sludge or septage at any certified site or facility. So that is wherever septage and sludge is land applied now underneath the solid waste management rules. So all of that authority about how the secretary determines or authorizes that land disposal or management is struck because it's no longer authorized to land apply septic sludge or biosolids. And that's really the end of the bill. It would take effect July 1, 2025.
Do members have questions for legislative council? You guys need to get into the Zoom room with your, yeah, you should be on there. Michael, how many times has this bill been introduced over the year? Or something like,
Oh, many times. I think Representative Jim McCullough introduced maybe 4 times, and then other persons have introduced very similar. I would say probably around 10 that I can recall.
Representative Bartholomew?
Would this apply to material coming from a composting toilet? Doesn't seem to meet any of the biosolids, septic or sludge. So my interpretation is no.
I know you're self-interested.
I
I will have to check with the agency on that question.
Agency's here.
We can, you like it?
Okay, I think it's a good time to transition. Is the agency in the Zoom room? You need to be in the Zoom room and you're getting in the Zoom. Great.
And if it works, Madam Chair, Eamon is going to, I think, take the chair, and I'm happy to just sort of.
Thank you.
Thanks, John. That's all. I was going to testify from the sidelines, but I can change that up. Thank you. Sure that. Yeah, and I'm gonna kick it on the screen, so.
Okay, welcome.
That's why I said it would drive. It's best. Let's do it. All right, so thank you. So for the record, my name is Matt Chapman. I'm the Director of Waste Management Prevention at DEC.
My name's Eamon Tuig. I'm the Program Manager of the Residuals Management and Emerging Contaminants Program. Residuals are basically biosolids and other materials you've already talked about.
So this is sort of an overview of the presentation that primarily Eamon is going to go through today, but sort of like explaining what we've been doing on PFAS and wastewater, kind of giving some conversation around what sludge and biosolids are, some of the septic studies we've done, some of the sludge studies we've done, talking about PFAS in land application of biosolids, what's going on in Maine, which is the one state that has a comprehensive ban. We can talk about Connecticut too, but I wouldn't put them in the same category. And then talk about some of the steps that we're taking with biosolids. So this is just sort of, I mean, we're starting off with just showing you, we have been doing a lot. And I think that anyone who works in the, absolutely.
Little public service announcement. I think we have time beyond what the agenda is showing, so I don't want you or Mr. Rathman to feel like we're not going to get to you.
Okay.
We're assuming that you can stay because you're the next on the agenda.
I am the next on the agenda. So, I think we're good.
I don't want any, don't feel like you need to rush.
Okay, thank you. So this is sort of an overview of the work that we've been doing over the past roughly 8 years to try and deal with, 7 years to deal with the land application of biosolids, starting in 2018 and collecting sort of material data on what it is we're dealing with, up to basically initiating a policy that really sort of restricts how biosolids are used and manages risk on how they're used in the environment. That policy is going into rulemaking this summer. I don't know if you want to go into any detail on anything here, but I think we kind of walk through most of these issues as we go through. I guess I think it's important before I turn it over to Eamon to just like preface that these materials, septic and sludge, regardless of the policy we pass on what we do with them, wastewater treatment facilities and septic systems create them daily, weekly, and so they have to be managed. And we basically have three options of managing them. You can land apply them, you can incinerate them, or you can put them in a landfill. And all of those options has problems associated with it. And our job is basically to try and maximize the options that are available there for wastewater treatment facilities and minimize the risk to the environment and the public. And so the rest of it, I'm going to hand it over to Eamon, and he can kind of walk you through some of the work that we've done. With that,
Thank you.
go for it.
Yeah, and that those sludge management options are all in that EPA federal rule that Michael was referencing, the Part 503s, which I don't recommend anyone read, but EPA set these three management options up. A lot of that had to do with the fact that there wasn't really any regulations prior to 1993. So people were really just sort of dealing with this material, however, including ocean dumping and including, not treating that sludge before putting it somewhere. So just spreading it on wherever, getting rid of it, basically. Vermont doesn't have an incinerator, so we really only have two of those options. Other states do have incineration. Matt mentioned Connecticut. They have a couple sewage sludge incinerators. There's one in New Hampshire. There's a couple in Massachusetts. No Vermont sludge goes to incineration. And I'm going to start with some simple definitions so that we're all in this, oftentimes these terms get interchanged and, you'll hear someone say septage, but what is septage, and they do matter, especially for the regulations. So this slide is just basically defining the difference between sludge and septage. The only real difference is one is in a wastewater treatment plant and one is at your house. Right. So if you're not tied to the sewer, you have a septic tank in your backyard that has to be maintained hopefully every couple of years. Your guy comes, or whoever the company is that you're working with, they pump that tank, the solids and the semi-solids that accumulate before your leach field, that gets pumped out. It has to go somewhere. It usually goes to a wastewater plant. A lot of Vermont is served by septic tanks. I'll get more into that in the next couple of slides. And sludge really isn't biosolids because it hasn't been treated. So sludge really just goes to the landfill. It could be incinerated, but it's not in Vermont. The other thing that happens with sludge is that if you're a really small treatment plant, you might, like a septic tank, pump your sludge tank and take it to a bigger facility. So there's going to be great examples of that all over the place. I live in Burlington, so there's 3 facilities there. The smaller facilities, one in the north end of town, one in the east side of town, pump their tanks and take it to the main plant down on the waterfront, and it gets managed there. Typically, sludge is either at that point liquid or it's dewatered. So those plants have to have the equipment to actually take the water out of it so that they can manage it, put it on a truck basically, and send it to the landfill. So all of sludge at Burlington, including sludge from Winooski, sludge from the 2 other plants, etc., and sometimes from other plants, goes there. It gets dewatered to like a 30% solid, and it gets trucked for management out of state. Montpelier receives liquid sludge from a lot of small facilities. It gets dewatered and sent to Coventry landfill, as an example.
What percentage is going to the landfill versus being land applied?
We're going to get there.
Great.
Yeah.
Representative Morris.
Thank you, Madam Chair. Are those considered Class A?
Nope, and we'll get there. We're right now, we're queuing it up.
Mm-hmm.
I think this might happen a few times where you're going to have questions, and of course, chime them out, but I think hopefully we'll be answering them as we go. So like Mr. Grady said, biosolids is essentially sludge that has been treated. It has been treated primarily for pathogens, right? There's a lot of bacteria and viruses and nasty things at the wastewater plant. That's why they were invented. That's why they're probably the most amazing public health invention ever, right? Cholera is a bad thing. Wastewater plants helps with that. So all of our sewage goes there, right? We filter it out. We take all the non-biodegradables out at the front end, and then we basically treat it. We use the bacteria to our advantage. They actually chew up and break down all the stuff, all the biodegradable stuff. And as their sort of life cycle goes on, they actually settle down into the bottom of the tanks and are pulled out. That is essentially sludge, primarily organic matter and dead microbial bodies. And it's full of nutrients. And basically, once you've achieved the federal standard, which is that pathogen reduction, and you've met pollutant standards. Now, I don't want to get too far into the weeds on those, but essentially the EPA set up pollutant standards for 10 metals, the bad ones, lead, cadmium, mercury, those ones. All the states have adopted these same rules, but states go further, right? So Vermont is one of those states that's gone further. So we have stricter standards than the federal level does on for several things. We also require a lot more testing, which I'll get into. But those two classes, Class B or Class A, which exceptional quality and Class A, for the sake of today, let's say are the same thing because they basically are. The only difference in that material is the level of pathogen reduction. So imagine you're composting. If you compost and you get a really high temperature, you're going to knock those pathogen levels really low, and then the material is essentially safer, right? The schematic is just basically a wastewater diagram, so I don't think we need to go in there. So to demonstrate, right, that you've made biosolids to the state or to the EPA, depending on who your regulatory authority is, you have to demonstrate through testing that you achieved this. So this is a list at the top here of the things that we test for in Vermont. The bacteria is critical because that shows if you've achieved your Class A or your Class B. Your metals, your heavy metals, the bad ones. Nutrients, so we know what the value of the material is. And now we're getting into the idea of a beneficial reuse. It's like a fertilizer. You get your nitrogen, your phosphorus, your potassium, also other micronutrients, magnesium, etc. Vermont tests for PCBs, which obviously is a big topic in Vermont. We've been testing for PCBs for a long time. To my knowledge, looking at the data, we've never had a detection. There's a caveat there, but I won't get into it. We also started testing for PFAS in 2020. So it's been several years now where we're collecting that information. Benefits of biosolids we've a little bit talked about, right? Like they build soil. Building soil is a really good way to mitigate carbon loss. So climate change link there. It recycles those nutrients. Instead of throwing them away, we get that phosphorus back, we get that nitrogen back, we complete the nutrient cycle. That's really important because phosphorus is such a big problem for, water quality in Vermont, things like that. Obviously conserves landfill capacity if we're not putting sludge in the landfill. And often biosolids are used in a way because there's such a unique material to restore degraded land. Superfund sites, not that we've done that in Vermont, I don't think, but quarries, mines, that's a great use for the material. It's usually a one-time use. You put it out there, it establishes vegetation, it sort of holds soil in place, provides structure. You get water holding capacity, so flood resiliency. So it's a really neat tool. What are the risks? As Matt said, there's always a risk with managing this stuff. Really what it boils down to, because I think there's a very low risk for people being exposed directly to like pathogens through all of the permitting and restrictions and testing. But they do contain PFAS, right? And we know that now, we've known it for years. And that PFAS is now being put back to the soil if we land apply it. So there is a risk there. So
Can we just pause for a second? Yeah. Testing for it, we know it's there, we're still going to do it. What does that mean, testing for it?
Yeah, so the testing has, first of all, there's no federal standard. There are a few states, and we'll get to that have interim standards. including Vermont. And that science is sort of this thing where it was like evolving and we were catching up. Even the testing methodology wasn't there at first. And we weren't quite sure what it all meant, to be honest. So just because something has something in it, right, doesn't mean it's a health risk. Like we allow those metals to be in the material because they went through a risk assessment to determine how toxic and what the risk is. We're going to get to that a little bit later because EPA has done a very preliminary risk assessment on PFAS and biosolids. Very preliminary. I don't think I answered your question, but I sort of just explaining.
Right, so are we just, I guess the question is, for any of those things that we're testing for, is there a standard for all of them? And so then does that standard then, if you meet or exceed it, does that result in a rejection of that
Yes.
biosolid?
Yes.
What is that standard?
We'll get to that for PFAS, and all the other standards are in place for metals, PCBs. There is no standard for nutrients because it's, it's not a toxic compound.
Okay.
So this answers your question before, and I apologize for all the numbers, but essentially, if you look at the bullet points, that breaks it down, I think. 27% of Vermont's sludge is landfilled. Pretty much all of that, or 80%, is going to Coventry. Again, that is dewatered and trucked. If you're a big facility, that's several trucks a day. And then the rest of it, 73%, is recycled to biosolids. That is a interesting, misleading number because over half of that 73% is done out of state. So we are exporting over 40-some% of all the sludge generated in Vermont. 40% of it is actually trucked out of state.
What recycle means spread?
So, for example, it would be recycled in New York or New Hampshire. And yes, it would go to a facility there that would treat it to biosolids. So it goes as like a raw sludge. And then there they process it via composting or other methods. They create a biosolid and then it's land applied in that state.
Or it could come back.
It could, in theory, come back.
Representative Chapman.
Yeah, so just digging into that further. So I think what I'm hearing is that of that 73%, some of that might just go into another wastewater system and then come out as their biosolids.
So at that point, because it's been dewatered and it's drier, it's basically going to be converted to a soil amendment, like a fertilizer. It's not going to go back.
100%, all of that 100% has been dewatered.
Not necessarily, well, essentially, yes.
And are those percentages based on weight?
Yes.
Weight. And virtually all of them are dewatered.
Yeah, because you can't. There are caveats with everything in this world. It is very, there's a lot of tangents. I don't want to get too far into it, but you can't take liquid sludge in a truck very easily. The idea is that you take the water out of it so you can truck it somewhere easier.
I'm asking, like, of your 3 Burlington facilities, are you capturing in that chart the amount of sludge coming out of all 3 of them? Or are you only counting the ones coming out of your main
Good
facility?
question. Only the main, because essentially, yes, that liquid sludge has gone through that whole treatment plant, right? They put it in, or it gets put into their dewatering system. So it's counted as part of the collective volume.
Right, so you're not counting some of that material twice by counting it coming out of one of the smaller facilities.
Nope.
And also sludges. Okay,
Yeah.
that's one question. Thank you for that explanation. My other question was around, I might have lost it. I'll come
Well, I'll
back.
step in for a second and just say, but dewatering it, I mean, that water contains those contaminants too. What happens to the water?
Goes back to the treatment plant. And we're going to get into a little bit of, I don't want to delve too far into PFAS behavior in a wastewater plant, but we have one slide on it and we can talk a little bit about that.
We could do a full show on that.
Yeah, and the other part, is it all right if I keep going?
Well, there's one more question.
Okay, go ahead.
My other question. So my other question is about these numbers. My understanding, and correct me if I'm wrong, is that 73-27, it's largely being made by the operators of the wastewater treatment plants, depending on sort of markets and partnerships. Like, what's going into that decision? You know, would it be easy for Burlington, say, to decide they're gonna switch where they send their sludge and all of a sudden these numbers change wildly? I'm trying to understand where the decision-making point is.
Yeah, that's a good question. And I mean, I think most of it is geographically based. And it's certainly economically based. That might be one of the greater drivers.
And I guess I'll just jump in. I mean, I think the other sort of answer to your question is like, in New England, our waste management system is not super resilient, right? We have an inadequate supply of landfill capacity. We have a limited amount of sort of capacity for biosolids sort of management and generation, right? So this is not, we can talk a little bit about Maine's experience and what ended up happening in Maine as a result of some of the choices that were made as far as biosolids management, but there are consequences of flipping switches in the sort of management regime. And there's not just sort of like, it's not necessarily an easy, quick transition.
I think what I'm getting out of this is that largely there might be sort of one financially viable way to get rid of your sludge, given your location, not like three totally different choices that you're choosing between that feel sort of equally available to a wastewater treatment plant.
I think generally that's fair or accurate. I mean, it really is location dependent. Sludge does cross borders. You know, most of these companies that take this material, whether it be at a landfill or a processing place where they're making biosolids, are private, right? So if you're in the center of the state and you've got a New York facility here and Coventry here, and they're owned by the same company, they're just going to do what they need to do based on their capacity. They might make a left or a right, and you have a contract. So, you know, most of the facilities are entered into, and Jeremy can talk about that later, but, you know, you typically have a contract with that waste management company to deal with your sludge, or with another municipality to take it for you.
Okay.
We talk a lot about sludge, but I want to just remind us that septage has a big part in this equation, right? We're generating a lot of septage in Vermont. 42 million gallons a year has to go somewhere, being pumped by trucks, right? Putting on trucks, driving on all of our roads. And the vast majority of that goes to Vermont wastewater plants. There are only 20 wastewater plants in Vermont out of 90 that take septage, and it's very geographically constrained. You don't want to pump a tank and drive 100 miles with a full load of septage. You will, very inefficient, you will lose money as a hauler. So we're going to talk about it, but what that means is there are certain wastewater plants that take a lot of septage, including Montpelier. And what that does, because it's semi-solid, is it just generates more sludge, right? So the more septage that's pumped, the more sludge we make. That's really the take home from that. We have,
And Morris has a question.
Sure. Thank you, Madam Chair. At what point does the stormwater play into this? Is that on the receiving side, incoming, or is that on the out sludge side? At what point does stormwater, and we have stormwater overflows, where does that come into, add into the volume?
so it would depend on the system, whether your system has a combined stormwater and sewer system, which many Vermont systems do. There was a big push for that. And now, ironically, we're unconnecting all of those. I don't think a combined sewer overflow really has nothing to do with sludge. But if the pipes are going to the wastewater plant and they're conveying stormwater, there's going to be, right, material in there. They screen out all the trash at the front end of the plant. But yeah, like, you know, leaves or whatever that make it through are going to end up becoming part of sludge, right? But they'd have to be pretty small. They'd have to be ground down. There's even grit removal at wastewater plants, like heavy stuff falls to the bottom, so rocks and things like that get taken out. But generally, I don't think it has a big influence on the amount of sludge generated. So we were fortunate to get some funding through our Water Infrastructure Division to do a statewide septic study in Vermont. Because we were very concerned that we have a lot of septic to manage, and we were hearing from facilities, hey, I'm at capacity like every day. I can't take anymore. Or haulers calling me, so-and-so is closed again. I have nowhere to take this load, and I have 5 emergency calls with septic tanks overflowing, especially during COVID. I was getting a lot of calls from people who were very concerned. And so we did this study, we hired a consultant. Other states have done this too. The take home from this is that we do have, as this entire state, if you put all the plants together on paper, we have the capacity. The problem is that we don't have sufficient capacity in certain areas. And really what that area is northwest Vermont, where we have the most people, the most septic tanks. And we have a couple of facilities, Montpelier and Richmond, taking a lot of septage. It's a bit of a vulnerability, so that if we lose one of those plants, and they do have to go offline for maintenance, planned or unplanned, things break down, right? Or I filled up my container of solids and I can't get it picked up for 3 days. Like the trucker isn't coming. I'm on a schedule. Every Wednesday and Friday they come. And it's Monday and I'm full. So they have to shut down. What that does is it shifts septage in other places. And we really have a very tight system that doesn't have a lot of flexibility. What's interesting is that we don't land apply much septage in Vermont. Other states, we used to, and that goes through the exact same treatment process as biosolids does. You have to demonstrate all the things, you got to get a permit, all the stuff. Maine just did a septic study, and even though Maine has banned biosolids, they have not banned septic land application. The reason being that the hauling distances from northern Maine to the next facility, wastewater plant that could take it, in some cases is 200 miles. So they don't know what to do.
They're not treating it before because it's septic, they're just.
They are.
There's
You
right.
cannot spread septage without treatment. It gets treated for pathogens and tested technically. In Vermont, it gets tested, and you have to have a site-specific permit to spread it with setbacks and seasonal limitations and all the things that come. It's very similar to like the manure seasonal, the seasonal spreading ban, all that stuff. I don't know if Maine has that, but I assume they do. Most states do.
But they're able to treat it before they spread it.
Yeah, you lime it, put a bag of lime in it. And technically you're supposed to screen it too.
Oh, that's the treatment.
Yeah. But that raises the pH enough to knock the pathogens down. It doesn't make a class A or exceptional quality material, but it does make a biosolid essentially.
And they're not testing for all those other contaminants.
I don't know what they're doing in Maine. We are in Vermont. All right. So in addition to septic studies, we are just embarking on a sludge study, statewide sludge study. We just selected a bidder. It's starting this month. I'm writing the contract this week. We have been fortunate to have a couple states go before us. Maine did theirs. Obviously, they needed to because they had just banned biosolids and they were seeing some pretty significant problems. This study basically shows that they lack sufficient landfill capacity to take all of their sludge. They also had, as we talked about earlier, a bunch of facilities that were managing liquid sludge through land application as biosolids. Now you can't do that. Now you have to dewater. I don't have the equipment to dewater. What do I do? So Maine has invested, I think it's like $50 million in grants. It's actually in legislation right now to provide dewatering infrastructure for wastewater plants. They also found that they lacked the bulking agents so sludge is very slippery. You can't just stuff a landfill with sludge because it creates instability in the landfill. Casella actually had to stop taking sludge at one of their landfills in Maine because they took too much sludge and they're worried like it was structurally unsafe. Can't have people driving around and they're working in there if things are entire walls of garbage are falling on you. So you have to have bulking agents like construction debris waste, C&D waste. So they were like short on C&D waste. So they had to like go and figure out where to get it. And they've also, because now they're taking, part of the reason why they're doing a landfill leachate treatment study is because through all of this, you can't talk about sludge and not talk about PFAS. So basically, even though PFAS is coming to landfills on a bunch of stuff, not sludge, right? It's in sludge too. So now they're doing a leachate treatment system study, just like we have done here in Vermont. And the last point there is just reducing sludge volumes. Massachusetts just did one. Part 1 came out. Part 2 will be out this summer. That's a $750,000 sludge study that Massachusetts did. Massachusetts generates half the sludge in New England. So it's a big deal for them. Again, similar story. They don't really have their own landfill capacity in state. They are looking for outlets. Nobody is planning on building new landfills in New England, as far as I can tell. And because they export so much, they are very vulnerable to what other states may do. And I would say we are in the same boat. If New York bans biosolids tomorrow, we are in big trouble. Like Burlington has nowhere to go. Right? So, yeah, I'll keep going. Some more questions.
Representative Morris.
Thank you, Madam Chair. Regarding the volume of sludge, is there, I know there's efforts around the state to look at changing from Class B to Class A by pressing and drying to reduce the volume. Is ANR looking at those programs as well, or opportunities?
I would say yes, and part of that is why we're doing this sludge study. I think without trying to like steer how that sludge study is going to go, I think that will likely be an outcome. It makes sense. Several of our facilities have looked into dryers. We've even had some demonstrations and pilot projects at facilities. Middlebury has had one. We have one sludge dryer right now in the state. It's in Bellows Falls. It's not a new technology. It does give you more options because you're drawing it to 90%. So you automatically qualify to be a biosolid through the rules, but you also then, if you don't spread it, you're trucking significantly less material.
So is that an option for other facilities to?
It's certainly an option. It would require significant investment. And they can be scaled size-wise, so it's really also depends on how big you are, right? If you're a really small facility, it might not make sense for you, but if you're a bigger one, it might.
So are we looking at
I think through this sludge study, we're going to look harder at that, yeah.
regionalization of the impact on the smaller ones versus a bigger facility that could?
Absolutely, and I think that's, so wastewater treatment facilities are already regionalized in their own way because the big ones take sludge from the smaller ones. So you get these big hubs like Rutland and Montpelier and St. Johnsbury and Middlebury, Springfield. Thank you, Southern Vermont. Don't forget Southern Vermont. And so if you were, for example, to invest in those facilities, yes, you would help the smaller ones around them because they would have an outlet to take stuff to. Yes, it's an important part of the equation.
All right, thank you.
Yeah, so I think part of the elephant in the room is always PFAS. Like I said, when you're talking about wastewater, biosolids, sludge, we have been studying it, but really what started to happen was we started to see these really horrible examples coming out of Maine of farms being impacted by PFAS. And certainly the PFAS came in on biosolids, right? It was transported, it was generated at a paper manufacturer, for example. This is just one example. That paper manufacturing facility was making coated paper, like Dixie plates, right? You pour water on those and it does not go in, right? So that's a coated paper. Cosmopolitan magazine cover, right? Is like for my kid, I remember that. You get like the water ring on it and it would just sit there. But like that is an industrial, right, source. They were adding PFAS to their system and it was being discharged to the wastewater plant through like an industrial pretreatment, allocation. And a significant portion of their flow in this example, I've heard anywhere up to 50% of their incoming flow to the wastewater plant was coming from this one paper company. So at the time, this might have been in the 80s, this might have been in the 90s. Nobody knew about PFAS, at least nobody in this sector. None of us probably. So what happened was that material was land applied on this farm probably many, many times. We don't quite know. And what happened is they found and tested milk and it had PFAS in it and it was a problem. So they figured out where did it come from, all this stuff. They went out and tested the soils all over the specific farm. And this is really a slide to show you how industrial impacts from PFAS can be really significant. And the numbers in soils scale-wise, if we look at Vermont and we've done a background soil study in Vermont, all the New England states have. If I go out and dig a shovel right over there in the woods, is there PFAS in it? Absolutely. It's just coming out of aerial deposition, rain, dust, and it's all over the globe, right? It's just everywhere. So if we call that 1 to 3, just doesn't matter what the unit is, right? We've tested all of our Vermont biosolid sites, 10, right? So that jumps to 10. When you look at that site in Maine, it's almost 1,000. So big jumps here in concentrations and risk. Not saying that there isn't a risk at lower numbers, but this is not a case we have in Vermont. We do not have industrial impacted sites that we've tested. We've not found anything. And we have looked at a lot of our industry, including our metal finishing industries, and we work with pollution prevention on those places. And we just don't have PFAS coming from industrial sources that we found. There may be some out there and we will continue to look for them.
So, and I think it just, again, sort of backing out, a lot of times, I think I probably said this a million times in my testimony, is that the reason we're focused on consumer products is because these numbers are coming from consumer products, right? This is basically you washing your clothes, you using your cleaning products, your discharges from your residential home into a wastewater treatment facility that ends up in the solid waste product that is coming out of those wastewater treatment facilities and the only way realistically, I mean, there are treatment options and, we can talk about, but that's not really a part of the presentation, but they are expensive and they're fairly new. So, all right.
Yeah. So if you're looking at I guess what Matt was saying there is if we go and test soils for land application sites in Vermont and they're on average 10, whatever units you want to call it, background is 1 and Maine some of the Maine sites are really high. Those really high numbers came from industrial, whereas Vermont's are very likely just domestic household uses, right? You pump your septic tank, it's got PFAS in it because of the things that you put down the drain unknowingly containing PFAS. Wastewater plants are receiving in Vermont primarily household sewage. Primarily, way primarily, we don't really have heavy industry in Vermont. So this PFAS is something we're using every day. We don't, as consumers, don't necessarily know we're using it, and it's coming off of us and going down the drains to the wastewater plant. So what happened, and we're going to get to that a little bit later more, but what happened in Maine since they prohibited biosolids, right? So Maine initially came out with some standards. They applied those for a couple of years, and then the legislation banned it. Forget the year on that, but
It's 22.
I think you're right. So they have been looking at pretty dramatic increases in managing their sludge. It makes sense. You take away one of the options. Now everything's going to the landfill. The landfills are charging more. It's costing the facilities more. Who's paying all of this? The ratepayers, right? The citizens of Maine are now paying roughly twice, in some cases, what they used to pay for sludge management. Now, is that such a big deal? When you consider that your wastewater plant is probably your town's largest financial asset, the most expensive thing to maintain. Burlington is bonding for $200 million right now in my town. And sometimes upwards of half of your annual budget is spent on sludge management. It's a lot of money.
So I guess I'll just also add, and I don't know that we didn't cover it, but so this is a topic when I get together with my regional colleagues, my colleagues from Maine, this is the one thing that's always sort of front and center on their mind. It's chewing up their existing landfill capacity at an incredibly quick rate. So they basically Juniper Bridge, their state-owned landfill, which is basically they've made the landfill available for sludge. It's taken the life of that landfill and decreased it significantly in sort of a rapid fashion. And they're now looking to expand or extend the life of that landfill. The other challenge is when Maine made the decision to ban land application, there were not readily available alternatives for doing it. Wastewater treatment facilities were basically stacking sludges at their facility in ways that really got to be unsafe. So, you know, it's in sort of underlining the importance that if the legislature chooses to do this, of making sure that there's a transition such that municipalities don't find themselves in the situation that Maine or all the unintended consequences that Maine went through in doing this. All right.
Yeah, so I think over the years, what we've learned is even though we may have lower PFAS levels in Vermont, I think business as usual is not really acceptable anymore. But also a prohibition, as Matt said, comes with some pretty substantial consequences. It's going to make things a lot more difficult on our municipalities and raise costs, and landfill capacity is a big concern in Vermont. So we got together and we started to talk about what we could do to mitigate risk from biosolids use. So if we're going to allow biosolids to continue, how are we going to take away some of that risk? And really what it means is we got to get the PFAS numbers low. And we did this soil study in Vermont. So we know generally what sort of the background levels are. So that's where we're setting our screening numbers. So it's basically like, if there's PFAS everywhere in the soils, let's make sure we hold it there. So we can't take it away. We can't remediate PFAS in soil. It's not really technologically or economically, certainly not economically possible. So that's the plan. And this is something we started in April 1, 2024. So we've had a year of this already. And we're the only state to do this. What's interesting also, the timing of this, what happened was through the market, essentially, we worked with the Agency of Transportation to talk to them about using biosolids in a manufactured topsoil. So typically in a construction project that you see all over, and you see the road torn up, or, you know, the adjacent side of the road is torn up, right? They got to revegetate that, and they've got to put soil back. Where do they get that soil? And a lot of times they need additional soil. What they'll do is they'll go harvest native loam, which is basically go scrape topsoil off of farm field, drive it in a truck, and go put it on the side of the road somewhere else. It's a pretty weird thing to me. This replaces that with the idea of you're building a soil out of this residual stuff. So it can have some biosolids in it, has some wood ash from various, like the McNeil plant in Burlington, has some other things in it, and they basically make a soil, and they make it to the spec that AOT wants. Then they use it in these projects. So a contractor will say, I'm going to bid on this project and I'm using manufactured topsoil. It actually saves money. It's cheaper and it recycles, and it's a pretty low risk use. It's also a non-agricultural use. So what we've seen is this dramatic shift in that people are saying, wow, this is great. This is working. We've got a screening standard that they all have to adhere to, but it allows them to sort of make a material that can meet the screening standard, and it's going to be used, right? And it's got value. So it's kind of been a win-win, and it's been going on for about 1.5 to 2 years, the use of manufactured topsoil.
So just to sort of add on this a little bit. So the interim strategy predominantly applies to EQ or Class A biosolids, right? So Class B biosolids, if you're land applying them in the state of Vermont, you've got to get a permit for the fields that you're land applying on, right? It's a different sort of more intense process. Class A, you know, back from time sort of ancient, they have been considered products and not subject to site-specific regulation. This effectively begins to change that by saying, look, you need to meet a certain suite of standards. You have to tell us how much you're bringing in and generally speaking, where they're going. We're looking at basically having people make sure they're not using them in an area where they might place groundwater or drinking water at risk. So, and we're trying to prevent people from loading an area over time with, you know, because again, these are sort of like when you're talking about soils, you're talking about loading over time, right? It's not like sort of a flash drinking water sample that you're concerned about. So we're trying to make sure that this is sort of not a repeated sort of use of these materials in that particular area. So I feel like we've tried to we've embraced and acknowledged the fact that there's a risk with these, and how can we go about managing them in a way that mitigates that risk to the best possible extent we can. All right.
Thank you.
Representative Chapin.
This is so helpful. Thank you so much for this detailed presentation. My understanding was that AOT would use biosolids as like a top application. So are you saying that there's a transition in how biosolids are used in transportation projects where it's being created into this manufactured soil instead of putting some topsoil down on a project and then putting biosolids on top of it? Is that accurate?
I think it's always used as the top layer. Because you're trying to establish that vegetation and also reduce erosion, which is really important for these projects. Because some of them have pretty steep slopes. But really up until working with AOT, they didn't allow, right? Biosolids weren't being used on those projects at all. So this is a relatively new thing. They actually added it to their specifications. And yes, biosolids used to be used or have historically been used on like quarry reclamation sites and things like that. Those necessarily weren't AOT projects. Those might have just been a private quarry that somebody owned. And then through Act 250, I believe you have to restore that quarry back to sort of how it looked before. So that's where they would come in and put that top layer on to establish the vegetation. I think that's still being done. Probably less.
Okay, I don't know why I thought transportation and AOT was a place that biosolids have been used for many years. Maybe that's more nationally.
Local projects, I don't know. It's possible. I mean, like Matt said, when EPA established the rule and made those two classes, if you got to Class A or exceptional quality, essentially once it leaves the facility, it's not really regulated. Right. It's like a compost, right? It's barely a solid waste. I mean, they deemed that material safe for general public use for everything. And it sort of existed like that since then. And this is changing that. This is sort of like, you had to always meet those pollutant limits, but we've now added that PFAS limit, and we're now asking folks to tell us where they took it. So now all of our operators are in the system giving me lat and longitudinal coordinates of where they dropped that material off, which is really interesting. We're the first state to do that. Tracking of this exceptional quality material, no one does that because it goes across state lines. It gets put into 50-pound bags and shipped from Milwaukee to golf courses. Like, it just goes all over the place. But we're getting a handle on where it goes. And we've also in 2020 established that anybody bringing stuff into Vermont has to register. So we know who's bringing it in and how much. Now we're finding out where they're taking it.
Great. So then the AOT piece is sort of creating a new use in a way that's very managed and controlled, and you know what that new background level is that should match the existing background levels, and ideally gives a new market for some of the land application.
I totally agree.
Great.
Yeah. And I think, these are the numbers that are out of that soil study. I don't know if we really want to talk about what, concentration units and what these all mean. I'm happy to answer those questions. I could just tell you that we're at background here. So these are very low numbers. If I go and talk to other states, they're like, it's basically a de facto ban. They kind of laugh at us. And I'm like, well, this is what we're doing. And, some of our facilities in Vermont that have historically made exceptional quality biosolids are no longer able to distribute them because of this. Right? It's not great for everybody. I mean, but I argue that if your numbers are that high, maybe you shouldn't be distributing them. Right. So again, in bold here, we've sort of got what they're telling us, what they're doing. It's a very new thing. We've had to train everybody on this. It's been a lot of work, especially for folks out of state, tracking them down, figuring out who's doing what. So our program's been hard at work, trying to keep everybody, educate people, help them do this. And I can say that our Vermont municipalities have been fantastic with it. It's the folks out of state that I'm still chasing, but for the most part, everybody in Vermont has totally complied with this. They might not be happy about it, but they've all complied, and it's not a rule yet. So they're doing it because we're basically asking them to. It's an interim strategy, right?
Yeah.
We don't need to get into this. This is just an outline of what happens. I would just say the one caveat to this is that you go to the place that you're going to put it and you test the soil there and the numbers are really low. And then you show me through a soil test or a calculation that you're going to keep the soil at that background level, we'll allow it. Right? At least that's the plan now. That might change when we go into rulemaking. No one's done that yet. I think generally people are like, okay, it's not worth it. If I can't make the numbers, I'll just not going to do it, but they could. So just want to make sure that that we're being transparent, that is an option for folks. Quick summary of other states that have done interim strategies like this. There are their numbers. I think this is all just, don't worry about the units again, just this is scale. For whatever reason, 20 is the magic number. These are not risk-based numbers. These are policy numbers. These are like, well, okay, if you're in this area, you're good to go. If you're above this, you're semi good to go. And if you're above that, you can't do this anymore. Michigan was the first to do this. Michigan had big problems in their biosolids from chrome plating. Chrome plating, not to get into the weeds, but you need PFAS and chrome plating. Well, that's changing, but you needed it in the past. It prevents hexavalent chromium from being released, which is extremely toxic. And so they were discharging high concentrations of a specific compound, PFOS, which is like the cousin of PFOA. And they found really high levels in their biosolids. They had to do something. So they set up this tiered system where they were like, if you're 0 to 50, you can keep land applying. If you're 50 to 100, you can land apply at a lower rate. If you're 100 to 150, no more land applying. That was just their way to like start getting at this stuff. They actually did industrial pretreatment at those facilities and the numbers dropped dramatically. So we did the same thing in Vermont. We just didn't find chrome finishers using PFOS really, which is good. We don't have the same problem. New York has interim standards, Michigan. For example, if you're Burlington and you're going to New York to Casella's biosolids facility, Casella is telling you, you need to be under 20. You can't bring that over to us. We won't take it. So as far as I know, Burlington's meeting it. And so just to add on to the amount of work that we've been doing, Vermont dedicated $1.25 million through ARPA funding to do a comprehensive wastewater treatment facility evaluation for PFAS. We did a whole year of testing, 4 quarters, influent and effluent at these wastewater facilities, and we just started to get the data back. We have not, it's a very draft report. It will be ready soon. You know, this slide doesn't really show us much. I just wanted to tell you guys that we've done this work, but it's a 2-phase project. The first phase was basically to take all this information in. Now that we have it, we're going to line it all up and we're going to take a look and say, okay, where should we be focusing? Do we have certain facilities where we can go into that town and work with that town and say, okay, let's go look to see, is there an industrial source of PFAS in your town? Because your numbers are kind of high, as an example, right? So we're doing that work right now. I think it's, in addition to the consumer product bans, it's a nice approach. Instead of just making treatment plants monitor and test and test and test and test and not do anything, it's like, we're going to take some information and we're actually going to go work with them. And we've done this before on a small budget with Middlebury and with Essex and got some pretty interesting data out of it. Really what it boiled down to is homes are the biggest source. Will we see that everywhere? We don't know, but we have leftover budget to go and do this work. So that really involves like popping manholes and taking samples. Like, let's say I know that pump station and that sewer system serves those 300 homes or just those 5 industrial buildings. Those are places we would sample and go, oh, that industrial facility does have a discharge of PFAS or not.
Just for, you don't have to go, broadly, what are those categories in the previous slides, those colors? There's no key to that.
Those are concentrations of total. So that's why I was a little hesitant to put this in there. When we test for PFAS, right, the evolution of testing has been significant. When we started, you could get like 16 compounds, right? There are tens of thousands of PFAS compounds. We're up to 40, and it's actually now a standardized method that EPA has released, right? So if you take and you test for all these 40 compounds, and you total that PFAS mass up, right? And you say, this is the total amount of PFAS coming into the wastewater plant. So you take the concentration, multiply by volume, get a mass. Same for the out, in and out, right? The wastewater treatment plants are not making PFAS. It's coming in and it's leaving. And it's actually transforming slightly in the plant, but that's into the weeds. But basically what this shows is concentration based. So the pink means essentially low concentration, and the light blue means relatively low concentrations. The drinking water standard in Vermont is 20. It's a drinking water number. These are basically under 100, I would say, is very low at a wastewater plant. And the majority of what we saw in Vermont means we've got pretty low levels coming in to our and leaving our wastewater plants. It is going in and out. Yeah, sorry, it's a little bit confusing.
Yeah.
And this is just a summary of our of that sort of in-depth wastewater study that we did where with Essex and Middlebury, where we actually went into the sewer. So this is like a sort of a schematic of a sewer map, essentially. And what I wanted to show this for was that pie in the middle, that bigger one. If this was to scale, would be 5 times the size of that pie. So it would be like, you know, this big. And that is from one residential neighborhood. So that is a mass load. So if we've tested industrial facilities, you see industrial valve manufacturer, personal care product manufacturers, right? They're actually, their load and mass is very small compared to like a domestic source. This surprised us. And we've seen it corroborated in California and other places, Maine and Massachusetts. So
Seems somewhat analogous to the Maine or what did you say? Where whoever the chrome plating was happening,
Michigan.
where there's a product, there's something people are doing that is getting concentrated in that effluent. And like, it's making me think of like going to those point sources, even if you will. What is the product these people are using? Is it their fabric softener? What is it? And how do we
One more.
get into that?
You want to do that one?
Yeah, I mean, so I think that is where the rubber meets the road. And that is where all the data, that's what we need to know, right? And it's very difficult data to get because the manufacturers and so do I even know that I'm putting PFAS into my product? Maybe, maybe not. If it's less than a certain percentage, I don't have to report it on the materials data sheet that accompanies that.
I mean,
And
I'll
even then it might even say proprietary surfactant. Like we're learning more and more and more. The use of PFAS is ubiquitous. It is when I mean everything, I mean everything. Is there a risk with some of that? No, if it's in your cell phone, probably no risk for you for exposure. But if it's in your laundry detergent, probably. If it's in the makeup or cosmetics that we're using every day, certainly. Is it in your stain treated rugs and your carpets in your house like I have in mine? Yes. So food packaging, right? So this legislation has done dental floss. This legislation is doing that work and tackling some of these products. Matt is really leading not only Vermont, but I would say a lot of New England in getting together to do these product bans on a broader level.
So a few things, right? I just want to make clear in both of these 2 slides, we're talking about effluent, so the liquid portion of what's coming out of the wastewater. So not the solids, but the 2 things work together, right? So, I think my experience working with industry is that they don't always know what the chemical inputs into their processes actually are. They don't know the formulation and they're not getting told by their suppliers that this is a PFAS. And sometimes even when they ask, they're not getting a response back. And that's been sort of our experience working with people. I guess the sort of last thing I would say, and I'll do the risk slide. The last thing I would say is this is a priority for us. And we've decided that, we're investing internal resources to basically build capacity within my division to have people available to work with industries to identify what sort of adverse chemical inputs are going into their plant and how we can find better alternatives to that. So we're trying to build out that capacity with the resources that we have available internally. Okay, EPA's draft risk assessment from earlier this year. EPA released a risk assessment. It's not a regulation. It doesn't model general public risk. And I think the takeaway and the thing that we're still trying to absorb and figure out where EPA ends up landing with this, it's unfortunate that there is so much chaos in EPA right now. Is, I think the clear takeaway from this is that there are risks in an agricultural setting from crop uptake and other issues associated with PFAS and land application, right? So I think we're, working with ag, trying to work through what solutions are and sort of like looking at coming forward with a set of a policy menu. I would probably say, I think that both the Agency of Agriculture and Agency of Natural Resources have the tools available to us now if we need to make a pivot with respect to this, that we could do it in the absence of legislation. This is a fairly tightly regulated set of inputs.
How many sites around the state have been used? I mean, am I correct in remembering that we typically would use repeat sites when we were spreading, that they were actually, and so how many of those are there? And are we adding to those numbers? I assume we're monitoring them more closely than other places.
Yeah, so this could be a long answer. We started testing, so we started with that timeline we showed at the beginning. We started testing wastewater sludge in like 2018. We saw PFAS in that sludge, and of course, logically, we're thinking, okay, which of these facilities is making biosolids, and where is this material going, and do we have concerns? So in 2019, we started testing land application sites. These would be permitted Class B biosolids and septage. So at the time, there was probably 20 of them total, maybe more. And that's just permit holders. So that there's more fields within those permits. Let's call it 60 fields in Vermont, all different acre. I don't have an acreage number off the top of my head. Not a lot of acreage. And these are municipal run for the most part, or in the case of a septage hauler would typically get a permit and have a field. We started testing 2019, 2020. We tested the soils and we tested groundwater. What was really nice was we had groundwater monitoring wells already set up at all these fields. We started testing on our own state dollar at first to see what the situation was. And some of the sites were fine, they weren't contaminated, and some were. So then we basically asked all the permittees to go out and do their own testing, and they did. Everybody complied, which was pretty amazing. And we did find groundwater impacts at some of these sites. Certainly we found PFAS in soil, which is not surprising. The facilities that had groundwater impacts were closed. Basically immediately. Cease and desist, stop spreading. Some of them, even when they tested and didn't find a contamination problem, were like, okay, we're good. We see the writing on the wall. We'd rather not get involved in what's going on here. We're just going to close our permits. So there's been a significant rollback. I mean, we went from 20 permits to like 3. There are 3 active Class B land application sites in Vermont. We test them a lot.
Where are they coming in on your?
They're either, well, they're below the groundwater standard or they wouldn't be operating. The groundwater standard is 20 parts per trillion. And that's for the sum of the 5 regulated PFAS in Vermont. Those folks that have had exceedances of that standard have been put on this path of basically a corrective action where you go, we have to basically establish, goal is to figure out what is the degree of contamination, what is the extent. So we do a lot of testing. So it's additional wells primarily, and also checking any water supply, like drinking water supply wells for like a neighbor that might be within, like we tested any neighbor within a quarter mile of that site who had a well. The good news is we didn't have any wells come back contaminated. So, even though local shallow groundwater was impacted, those drinking water wells were not. And typically we already had setback and restrictions on how close you could site one of these fields to a well. That probably helped. Maine has not seen that. They have seen impacts to drinking water. We have not.
But you didn't speak to the soils impacts and
Yeah,
whether or
so,
not these sites are being used for agriculture actively.
so in the past, it was required that they were used for some agronomic value. So some agriculture, these weren't places to just go dump stuff. It was like, we need to do something, you need to be growing a crop. They were non-food crops. Typically, all of them were in feed corn or hay. That was really it.
Right, but in the case of Maine, that was transferred through the cows into milk. And so what? You still haven't said what the soil concentration.
So we could,
Allowable on what that lay out in the active sites.
yeah, so there is no soil standard other than a human exposure dermal or like inhalation standard, which is really high. So there is no soil standard, and I'm not aware.
But you presented us a soil standard for the V-Trans or the fill soil.
That's the material standard.
What are these coming in at?
The soils
Or the
or,
concentrations on.
Concentrations on these.
yeah, so they averaged about 10 parts per billion. And that is
Actually, if we go, sorry to scroll back quickly, but.
that would
this
be for the
is-
5 regulated compounds in Vermont. And I think the range was anywhere from essentially background up to like 35.
So it's basically the middle box here. So you basically see from 9.8 to 11.9, with the highest value being 35 parts per billion.
Yep.
Yeah, and I think we also all recognize that 20 parts per million for water is quite high now by our understanding.
So you can't, so this is the challenge when you're crossing media, right? So you can't look at water values and these values and look at them similarly. I can't remember off the top of my head what the risk-based value is for human health risk on soils, but we've never seen it in the state of Vermont. It's a considerably,
Yeah, I wasn't actually crossing media. I was switching topics.
okay,
I
sorry.
was just saying that if your standard for the groundwater contamination is 20, that's pretty high. Like if that's what's shutting a site down, that seems like,
So that's parts per trillion on a scale.
what's our,
And soil is part per billion, so there are 1,000 units apart.
yeah,
So
I get it.
water really small, soil in the middle.
I get it.
Sorry.
Where's the EPA headed with drinking water standard?
I have no
Where
idea.
were they previously headed?
EPA is currently at 4. So Vermont is
Brilliant.
parts per trillion for PFOA and PFOS. It's higher for other compounds, and it uses a hazard index, which is more complicated for sort of across a set of compounds. Vermont is, EPA has basically, I'm not going to try and predict where EPA is going to land. It does not look like they're going to keep those values. So we have some concerns around that. We're currently in a rulemaking process to basically align our drinking water rules with the EPA standard, the 4 part per trillion standard. And we're also looking at amending our groundwater rule to align it with the 4 part per trillion standard. Now, all of those actions require rulemaking processes, none of which is completed yet.
Representative Austin.
Did you say trillion or billion?
If I said it's 4 parts per trillion with respect to drinking water values and groundwater values.
Detail.
Representative Chapin.
I just got a little bit confused there. Is that a combined for all 5 PFAS at
Was
4,
once.
or were they different?
So
And
it's-
are they additive? So then you could have 4 parts per trillion of this PFAS and 5 parts. Does that mean 9?
Right. So they're different, right? So the standards are different. EPA has established numeric criteria for each of the, I believe, 6 PFAS compounds that they are regulating. I don't know them off the top of my head. They've also created what's called a hazard index, which is kind of like the sum of the PFAS, but again, it's an approach we actually use when cleaning up contaminated sites, looking at sort of non-cancer risk often. And it's one that EPA ended up adopting for not PFOA or PFOS, but the other compounds that they're regulating.
So my question is, are they additive?
They're not. Again, so the hazard index is kind of like them being additive, but it's not.
One that's not PFOA or PFOS.
Correct.
When do you stop drinking the water?
Or do I stop drinking the water? I think it's fair to say that both DEC and the Department of Health's position is when you're looking at PFOA and PFOS, the lower the concentration, the better. I mean,
Okay.
Yeah, we've all been waiting for this EPA thing to drop for some time. So we've got a lot of data and we've looked ahead to see where we would be if the standards change. It doesn't change much in terms of where we're at. I just want to reiterate that, like what Matt was saying about, you were asking a lot of questions about agricultural use, like those permitted sites are in ag use, they're non-food crops, but like the amount of testing and monitoring gives us some level of certainty that, we can stay ahead of a concern. But I think the science is so rapidly evolving and needed. There are a lot of questions, and working with ag is basically our way to make sure that, we're trying to protect farms, and we certainly prioritizing it. Like it's not something that, we're working with ag pretty closely on all this stuff.
all right.
Yeah, the last slides are just, you had asked about where is PFAS coming from, and there's been some really interesting studies out of New Hampshire looking at cleaning products, and I know cleaning products is on. I think it's still
It is
in whichever, I forget what the bill
page
number is.
230.
So I think there's enough data out there to show that there's a significant problem and a significant source when it comes to cleaning products like carpet cleaning, floor strippers, floor waxers, and what surprised me was laundry detergent.
Can you just talk a little bit about laundry detergent?
Well, I don't know a whole lot about it, except that they found numbers that are really high. Looking at these charts. And I'm also thinking about, like, I might not strip and finish my floor that often. A school does, a hospital does, but I don't in my house, but I wash laundry every day. I got kids, like, so it'd be really nice to know which ones have it and which ones don't. They won't release that information probably, but why don't we just say no more and laundry detergent, and we don't have to worry about which ones have it in it and which ones don't.
Trying, do you have a question?
I was gonna just answer her question about the laundry detergent, in that when you sample for
Can you
PFAS.
just say for the record who you are?
Oh, I'm sorry, Jeremy Rathman, from the town of Middlebury. To answer your question about laundry detergent, when you sample for PFAS, which I do at the wastewater treatment plant, there are very specific instructions about what you wear while you're doing the sampling, because you're detecting it at such a low level. One of them is you can't wear any clothing that's been washed in a fabric softener, because they believe that most of it has PFAS in it. So we're detecting to such a low level that, yeah, you actually have to be careful what you're wearing when you're actually doing the sampling at the plant.
We'll wrap it up.
Yeah, let's.
Go ahead, Representative Sedgwick.
So we're trying to get PFAS out of all these items, and presumably over time, we will be doing that. Do you have any sense of how long it will be before these numbers start coming down to where the problems that we're talking about start to become less of a problem?
That's a difficult one. I would say, there have been success stories like the Michigan story where they worked with the chrome platers, basically turned that tap or that source of PFAS off, and the numbers plummeted. But I think there's going to continue to be a significant background level of PFAS. And I don't even want to say the word background because it's not natural, but we see PFOA and PFOS are two compounds that have been phased out for many years now, but they're in so many products that they're still around. It's going to take a long time, and they don't break just because we move them from one place to another. I'm trying to explain. They're a forever chemical, right?
No,
So
I
it's going to
understand
keep
that.
cycling.
Sure, but as
Yeah.
we're talking about biosolids and
Yes.
how and how they're in biosolids because of the stuff that we're using that we're flushing down the toilet in our drains. And so I'm just sort of wondering, like, yeah, if it's everywhere, then we're not going to deal with that problem. But in terms of not making the problem worse by land application, are we looking at like years, decades, like before, like so much of the stuff is out of the system that we're at those sort of background levels?
So I guess I'll say like there are some things where you remove the source, like laundry detergent, right? Where you're going to see pretty rapid changes based on that. But then when you think about, you clean your carpet has PFAS in it. You don't change out your carpet quickly after you've bought it, right? These things that you've made an investment in your home, from your clothing to your carpet to your other products, they're going to go through their life cycle. And when they get replaced, presuming we have an effective system of bans in place, it will reduce over time. How long is that? I mean, I think it's frankly, it's sort of as commercial products get changed out in people's lives, you'll see reductions take place over time as these bans become effective. I'm sorry if that's not the best.
No, I didn't
answer, because I don't
expect you
think
to give me
there's
like
one.
any sort of, I'm just trying to get like if you have some sort of a sense. So when we're talking about how we're going to be managing biosolids, are we thinking like this isn't going to be interim rules that we're going to be put in place that we expect to change in like within our lifetime? Or is this kind of like we just need to change the way we're doing things permanently because because the time horizons are so long that we're not going to get these things out for such long periods of time? Just a sense. I'm just wondering.
Difficult to answer. I mean, I would say if we were to adopt these screening numbers and put them into rule, I don't think we'd go back up with higher numbers,
Yeah.
right? So they're like kind of once you go restrictive, you can't be with them. I don't think we're going to go less restrictive.
Oh, I don't want you to be less.
Yeah, no.
That's not what I'm trying to get at.
I think that this problem, it's not a short-term problem. It's a long-term problem, right? It's not something that you're going to see. Our problems are nowhere near what other jurisdictions have as far as sort of the concentrations they're seeing in effluent or wastewater treatment facility sludge. So I mean, the problem is I can't give you like a time horizon, right? Because I think the other challenge that we face is that our analytical capacity to even test and see the PFASs that are out there is limited, and there are chemical sort of reactions that are happening that change these PFAS in the wastewater treatment process. It's just hard. This is, I think, I've said this before. The reason we call these emerging contaminants is because there's a lot we just don't know, right? And I think that the science has been evolving, and we've learned more, and we've been able to come up with management strategies to deal with this. And I think that that's part of why Eamon and I are here, right? Is to make sure that we're doing everything we can to drive these numbers down as far as we can and manage risk as well as we can.
Yeah, no, saying that you just don't have enough data to make a good,
I don't think
make even sort of a wild guess is a perfectly reasonable answer.
I think that's my answer.
Fine.
All right, let's wrap
Wrap
up.
it up.
Yeah, I mean, I think I've hit on some of these takeaways throughout the presentation. These are heavily managed and regulated materials. We are all contributing to this material. We're generating it every day at the wastewater plant and our septic tanks. The material has to go somewhere. Landfill capacity, declining landfill capacity is certainly a concern. It's part of the equation. We've seen that the consequences of a prohibition on biosolids land application in Maine. And, I think we're, like I said, with this strategy is there with the biosolids, at least to stop the business as usual, but to maintain this as an option for our municipalities with, mitigated risk. And as we start the rulemaking process, which is just starting now, we're probably going to see some, proposals and asks and comments for how these rules are ultimately adopted. We've just talked about reducing PFAS in products through product bans. That's probably the most efficient way to get numbers down in our solid waste residual materials. And just, I gotta always put a plug in that we gotta continue to invest and incentivize our wastewater plants to keep doing the good work they do. It's a critical component of our society and they get overlooked. It's really expensive and, you know, Vermont, like many other states, has infrastructure challenges when it comes to wastewater plants. So we need to continue to think about, you know, helping ourselves by keeping these plants in good shape and giving them options of how to manage these materials.
Right. Thanks for your testimony. We really have to move on. We have another witness.
So-
Representative Labor has a quick question, but we do need to move on now.
Earlier in the discussion, you talked about landfill capacity and that, to the best of your knowledge, no explorations have been worked out with other geographic locations. My district is Orleans County, that's part of Coventry, it's in that county. And I've been told by the operators themselves that landfill capacity probably be achieved prior to the termination of the permit. So given that, and from the other discussion here this morning, it would look like perhaps more waste, solid waste, is going to end up there if you can't put it into the soil. I think. But so my question is, has there been a team set up to go throughout the state looking for another site that is not near a watershed? Everything from underground drain 3 is the biggest concern of many of my constituents, many whose name I'm sure has come to your emails in the past. I can't encourage you enough to find another site soon and lock up that contract. That's it.
Thank you for your testimony and for your work on this. I guess I actually wanted to just say, yes, we are the conduits for this, but we are not the source of it. And you can buy products that label the ingredients in those products and that don't include these chemicals. You can do that. And I would say that we end up playing whack-a-mole because of federal policies that are inadequate. And I do think that it's important for us to realize there are different ways of regulating hazardous materials, toxic chemicals in our environment. Our society hasn't chosen to do that so far.
Yeah, I don't disagree with that. And I guess just to add, right, like, I mean, I don't think this is a consumer choice problem. This is a product development problem. You can't expect people to have, go through large lists of products and choose the PFAS-free ones. We need to force companies to be more responsible in how they're dealing with
And
this.
we have companies in Vermont that are producing clean products. Thank you for your testimony. I'm going to take a 5-minute bio break and then welcome our next witness. We do have the opportunity to hear from a practitioner who is boots on the ground with a lot of what we've just learned. Take a 5-minute break.